So the predictive modeling, once a set of historical data is collected for the analysis, then the scientist or analyst will create an algorithm for the collected data, and then they will generate to predict the model. Okay, so that is what we can call it as a predictive modeling, or simply if I want to say, it's a process that is used as a part of the predictive analytics to create a statistical model for the future behavior. So what could be the future value, or for future event we can able to predict it. So generally in predictive modeling process, these are all the steps involved in the predictive modeling process. First one is a problem statements. First we have to define the objective of the problem statements. So we should have to understand the problem, what exactly needs to be predicted. Suppose for example, if I want to predict a rainfall, so based on the some parameters, based on the air pressure, humidity, temperature, wind, cloudiness. So based on these parameters, we can able to predict whether the rainfall will occur or not, whether the rainfall will come or not. First, we have to define the problem statement clearly, and then we have to collect the data. So according to the problem, we have to collect the types of data that is required for your problem. So first you have to gather the data based on the manually also we can gather it, or by web scraping, or by using some online repository like a Kaggle, UC repository. Using those repository also it is possible to collect the data. So once we have collected the data, then we have to go for the data pre-processing. So because whatever data we have, that obviously will be having a missing values, redundant variable. Even you may have a duplicate values also we have it. So that it should have to be pre-processed. So once we have pre-processed the data, then only you can able to apply some techniques, whatever techniques you are going to, or whatever algorithm you are going to apply, then only we can able to get the correct predictions. Okay, so after collecting the data, we have to go for the data pre-processing, and then we have to go for exploratory data analysis. So actually it involves understanding the patterns and the trends in the data. See, usually in the rainfall prediction, suppose if there is a sudden fall in the temperature, means then what we can say that there is a possibilities of rain. Okay, so there should be some correlation between the two attributes. Okay, so that is what we can specify in the exploratory data analysis. And then what we have to do, we have to build a model. Okay, so when you go for building a model, actually there you are having a two steps are there. One is a training data, another one is a testing data. See, so data can be classified into two. Training data, generally for the given data set, we using some classification algorithm, we try to build a model. Okay, so, and then we will test the data, how far this classification algorithm works perfectly. Okay, so if we get a correct output, then we can say that the algorithm is perfect, or otherwise once again you have to train the model until you get the perfect output. So that is what we have to first build a model, and then we have to go for the evaluation. So after building the model for the training data set, or then the testing data set, we have to check how far the testing data set works perfectly. Okay, so we have to evaluate your model, and then only we have to go for the predictions. So once the model is evaluated, and then finally we have to go for the prediction. So prediction, it can be a categorical data or a continuous data also we can have it. So these are all the general process we are having it under a predictive modeling. So these are all the top techniques, predictive modeling techniques we are having it in the predictive model. One is the classification techniques, classification, clustering, time series modeling, and then the forecast model, outliers. So these are all the top predictive modeling techniques. We'll see one by one. Classification technique. As you all know, classification comes under the category of supervised learning. Supervised learning means, suppose for example, along with the teacher, if you try to learn the model, or if you try to learn, then that comes under the category of supervised learning. So here the class level will be known. So that we can call it as a classification techniques. So in most of the industry, they used to adopt the classification model. Generally, they used to retrain the model with the current data, and then they used to try to get the solutions for the upcoming data also, for the new data also they can able to predict it. So generally these classification models are customizable and are helpful across the industry, even banking system, medical field, even fraud detections. Most of the cases, most of the applications, they can use this classification algorithms. So here in the classification algorithms, there we have a neural network. So neural network, already you know that there we have a multi layers we have it. So mainly this is inspired by the human main. There we have an input layer, output hidden layer, and then the output layer. So here, how the human brain is going to work in the same way, the neural network also is going to work. The main drawback here in the neural network is training data. Training, it will take so much of time actually. We got a funded project in the year 2014. So there we applied a neural network for 1 lakh data set. So there it took more than 1 day to get the output. Okay, so for 1 lakh data sets, if you apply this neural network, the training is the biggest problem in the neural network. If you have a huge data set, it will take so much of time. But once the training is pakka, then easily we can able to get the output. Pakka output we can able to get it out. So that is the advantage we are having it in the neural network. Training, it will take, drawback is training, it will take so much of time. Once you have trained the data, then easily we can able to get the output, perfect output we can able to get it. Even we have a decision tree is also there. Decision tree also, it looks like a tree structure. There we have a internal node is there. Internal node, they used to test the attribute. Even we have a branch that the branch will give you the output of the test data, and then the at last you'll have a class label. Class label, there we can able to say whether the disease will come or not, whether the disease is there or not. Some class labels we can able to predict it. Even we have a regression technique is also there, that comes under the category of a prediction. So prediction, there is a slight difference between classifications and prediction. Classification, generally it is used to predict the class label. But in case of prediction, that is used to predict the missing values. Missing values in the sense, suppose if you have years of experience, if you have, then easily we can able to predict the salary details, we can able to predict it. So based on the years of experience in the teaching, we can able to predict the salary details. So mostly in prediction, we used to have a numerical data, we used to have it, but in case of classifications, we can always class label must be there, categorical data. There is a slight difference between classifications and prediction. And then we have a clustering concept is there. So clustering, by the word itself, we can say that we are going to group the data. Similar items and all, we are going to group it into one category. And then there also we are having a different algorithms, k-means algorithm, k-medoids, and then grid-based clustering, hierarchical clustering, model-based clustering. There are different algorithms are there, agglomerated clustering. So using those algorithms, we can able to group the data. Here also we have a hard clustering is there. So here we are going to determine, or we are going to put each data point into one cluster. So that we can call it as a hard clustering. Soft clustering means that it works based on the probability. It works based on the probability in the sense, for the same data point, we will say that 0.5 or 0.7 chances are there in the class 1 and 0.3% chances are there in the class 2. So this is how usually hard clustering, the data points, either it will go to cluster 1 or cluster 2. Any one only we can have it. But in case of soft clustering, both the classes will have that particular data. And then the next one is a forecast model. So in the forecast model, this is also one of the most prominent model in the predictive techniques. So this is also very popular, and it works on anything with the numerical values. So based on the historical data, we can able to predict what could be the future value. Suppose, for example, a call centers can use a forecast analysis to predict how many support calls will receive per day. That we can able to predict it, or otherwise weekly also we can able to predict it. Based on the historical data, they can able to predict per day how many calls they can able to receive it. So this is also one of the important technique in the predictive analytics. And then the outlier model. So outlier model, this model works by analyzing the abnormality or outlying the data points. So here the outlier is actually it's a data object that deviates from the rest of the objects, or simply if I want to say error data, we can call it as an outlier. So for example, suppose in a banking, suppose in my case itself, usually I'm using HDFC Bank. Usually I won't go more than 20,000 per month. So one day, one of my faculty asked me for a mobile iPhone. I purchased it for 70,000. So there immediately I got a call from HDFC Bank, and they got it confirmed from me. After that only they have passed that order. So because they know that my range is, it won't go above 20,000. Okay, so sometimes if it is going beyond that limit, means that will come under the error data. So from their HDFC point, customer point, what they'll think that, okay, someone, they might have misused this data. Because of that only they have called me, and they have confirmed that whether I have ordered that particular item or not. So based on that only they have approved that particular product. Okay, so ordered. So that is also, we can call it as an outlier. So mainly to identify the fraud detection, for that purpose only we are going for this fraud outliers. Or we can able to analyze the customer buying habits also, we can able to analyze it. Based on that, they can categorize the people, and they can give the benefits, and even they can able to analyze the sometimes the even in the banking system itself, so one of my colleague also faced some problem. Suddenly she got a message, continuously message from the SBSC bank, like 5,000 detected, 10,000 detected, that to international call. She didn't enable that international facilities in the SBI, but immediately she got a message continuously that so and so amount is detected continuously. She lost nearly 50,000, and after that she reported, she blocked that particular card, and immediately she reported to the customer care. After that, after some negotiation, she paid nearly 10,000. That also she didn't purchase anything, but after some negotiation, because she didn't enable that international call, but still she somehow they have enabled it, and some of them somehow she faced that problem, and she talked to the higher official, and somehow she managed that particular problem. So that is also will come under the fraud detection only. Okay, so these are all the examples we are having it for the outlier detections. And then the next model is the time series model. So time series model, this model is for the predicting the future event based on the past historical data. So for that purpose only we are going for this time series analysis. So mainly this model will analyze the data set based on the historical data, and we can able to predict the future events. For that purpose only we are going for this time series data. So for example, if suppose in the hospital, if we are having a number of stroke patients admitted for the last 4 months, if I want to predict how many patients will come in future, or in the next week, or in the next month, or in the rest of the years. Before itself, if I want, we can able to predict it. Okay, based on the previous historical data, we can able to predict the future events. We can able to predict it. For that purpose only, we are going for this time series model. So time series data, so here the data, so generally in the modern world, if you take, time is an essential factor that needs to be considered. So here, suppose if I want to predict the customer analysis, it can be a financial investment or electrical consumption, or if I want to predict the positive growing stocks in future, if I want to do some kind of analysis, or some kind of predictions, or some kind of investments if I want to do, then time series plays a major role. Okay, so in the time series analysis, actually it is a collection of observations on the value that the variable takes at the various points in the time. So based on that, the previous historical data, we can able to predict the future data. So the data can be of three categories. One is the time series data, cross-sectional data, and then the pooled data. So in the time series data, it's a collection of observational values taken at the different time frames, or if I want to say, for at a different particular time, the values will be keep on collecting it, so that we can call it also time series data. Next one is a cross-sectional data, means there you have, it consists of the several variables recorded at the same time, that we can call it as a cross-sectional data. Pooled data means it's a combination of both time series data and then the cross-sectional data, both together. We can call it as a pooled data. So this is a definition for the time series analysis. So time series analysis is a type of analysis of the data that is used to check the behavior of the data over the period of a time. Okay, so mainly it is used for analyzing the data, and it is used to check the behavior of the data over the period of time. For that purpose only, we are going for this time series analysis. So these are all the applications we are using it for the time series analysis. First one is a rainfall measurement. So based on the temperature or humidity, air pressure, cloudiness, based on this we can able to predict the rainfall, or we can able to measure. There are some factors we can able to measure the rainfall, because rainfall, if it is huge rainfall, means there is a chances of landslide also. So there also we'll use the time series data. Even automated stock trading also, they are using this time series data. They are going to analyze the historical stock prices to identify the trend, current trend they can able to identify, and then based on that they can forecast the future price, they can able to predict it. Even in the industry also they are using this forecast, because in the industry many of them, if I want to know the particular product, particular region, what is the overall sales, based on that they can able to concentrate the loss. If it is a profit, well and good. Suppose if there is any loss, then they have to analyze in detail, they have to analyze it, which region, which country, which part, in-depth analysis they have to do. Then based on some kind of analysis they can overcome from the loss. And then the temperature reading based on the sales forecasting also. These are all the applications we can use this time series analysis. So here even we have another techniques is also there. Time series forecasting is also there in the predictive modeling. So actually it's a process of predicting the future value with the help of some statistical tool and method used on the data sets with the historical data. See, based on the historical data, we can able to predict the future value. So that is what we can call it as a forecasting. So again, here in the forecasting also, these are all the applications we are using it, predicting the stock price, even the whether we can able to predict it, whether the tomorrow rain will come or not, or we can able to predict the sales of the product. So these are all the applications we are having it for the time series forecasting. Actually, why we should have to go for this time series analysis? See, generally it helps in analyzing the pattern of the data over a graph, and then based on the graph we can able to predict it, whether it is going to be an uptrend or a downtrend in case of a stock market. If you take so based on the graph itself we can able to predict it, whether the trend is going to go up or down. So based on that we can able to avoid the loss. We can able to, even in the business also, we can able to check each and every product, whether it is moving in a positive directions or in a negative directions. Based on that we can able to conclude something, whether we are getting a loss or profit. Okay, so if it is in a profit, fine, but if it is in a loss, means business people, they can take immediate decision and they can overcome from that. So even it helps to compare the present trend with the past trend, and then they can able to predict the future trend. What could be the after 5 years, what could be the output of that particular product? We can able to predict it, and even it helps us to understand the correlated seasonal trend of the data. Even it also helps in the quality control process to predict the quality trend over the trend. See, for these are all the application. That is why we need a time series analysis. Okay, so mainly if whenever the data, if we are having related with the time, then we can apply for the time series analysis. Mainly we will try to analyze the historical data. Based on the historical data we can able to predict the future values or future trend. It is possible to predict it. For that purpose only we are going for this time series analysis. When we are not supposed to use this time series analysis, means suppose if the values are there constant, if you're not changing it frequently, then in that case the time series analysis is not at all required. Because in stock marketing, if you take every time the values will be keep on changing it. Okay, so in that case, the time series analysis, tomorrow what could be the stock value if I want to predict it, then easily we can able to predict it. Okay, so but if the values are constant, if we are not changing it frequently, then time series analysis is not at all required. So when the values can be represented by using the functions, suppose if the values are having with the functions like a cos or some other functions, if we have, then the time series analysis is not at all required. So next one is components of the time series analysis. So there are the various reasons which affects the values of the observations in the time series. These are all the main components of the time series. So first one is based on the trend, seasonal, and then the random error or irregular fluctuations or cyclic variation. These are all the 4 components we are having it under the time series. So the first one is a trend. See, so see here the general direction in which something is developing or changing, either in the upward directions or it may be in a downward directions. So this is actually one of the most important component for the time series analysis. So this trend generally it increases or decreases in the value over the period of a time. So in this picture, it shows that it shows the upward directions in the time series data. So this you can consider it as a stock market. Sometimes you may have it as an uptrend will be there, sometimes downtrend will be there, and then the uptrend will be there. So for some period of time, always it will go for the uptrend. After some time, due to some recession period, if you take it out for the particular In case of IT companies and all, if you take for the particular period, if there is any recession, all IT companies will come down actually. So they'll be facing a downtrend. So that is what we can call it as a trend. So it depends upon the situation, or it depends upon the season, it depends upon the current situation. So it may it may go to the upper end, or it may be in a downtrend. So next one is a seasonality. This is also another important characteristics of the time series data. So here it depends upon the season actually. Few season, if you take, always few products will be high actually. For example, in summer season, if you take, the sales of ice cream will be increased. Always it will be an uptrend from April or March, April, May, June. These 4 months, ice cream sales will be more. During the festival season, if you take like a Diwali season, crackers will be more. It depends upon the season. Okay, so it may be a seasonal effect. We can calculate it based on the yearly, quarterly, or monthly. Also, we can able to calculate it, or even you can have based on the holidays or based on the changes in the weather. Also, we can able to forecast it. We can able to forecast a model. Okay, so that is what we can call it as a seasonal trend. And then we have a irregular fluctuation is also there. Irregular fluctuation means sometimes there may be a sudden unpredictable calamities will be there. Suppose, for example, there may be a sudden flood or earthquake, means that is unexpected, and there may be some fluctuations in the data. So that type of examples we can call it as irregular fluctuations. Or during corona periods, if you take, there also some fluctuations also will be there. Their medical products and all, most of the products will be very high actually. That too, even the paracetamol also, the number of sales will be more. So due to some unforeseen or unpredictable forces, the variations may be due to, it may be a flood or earthquake. These we can call it as a irregular fluctuation, or you can say it as a random error also we can say. Okay, so the random error in the sense there may be a noise that present in the data, that also will affect the accuracy of the forecast. Okay, so that also should be taken into the considerations when you go for the forecasting model. And then last component is cyclic variations. So in the cyclic variations, over the period of time, it will allow us to understand the business cycle, because every organizations, if you take it out, they have to go through these 4 cycles. Like always, all the organization, we cannot have it as a boom. We have to go through all these 4 cycles in most of the businesses. So prosperity or a boom, recession period or depression period, recovery period. During the corona period, if you take it out, IT companies and all, if you take, definitely they might have gone through this recession period, a depression period also. Now slowly they have recovered from that, and now it is in somewhat okay. Okay, so on any organization, if you take it out, they have to go through these 4 cycles. They have to go through this. So this is what you can call it as a cyclic variations. So these are all the 4 components they are having it for the time series. So there are 2 different classes of time series data. One is a stationary data, another one is a non-stationary data. Stationary data means here the data do not change over the time. So, or in some other words, the data does not show any trend, seasonality, or even the pattern. You cannot find anything. From this figure, if you see, see here, you cannot able to find anything actually. You cannot able to find any trend, seasonality, or you cannot able to find out whether it is uptrend or downtrend. Nothing you couldn't able to find it. So that we can call it as a stationary data. Okay, so here the only possibilities is a random error. So, but in case of non-stationary data, if you take there, it shows the trend or the seasonal effects, so you can able to find it out. See here in this case, if you take it out, here clearly it shows that the downtrend is there. After that, the uptrend is also there. So this is what we can call it as a non-stationary data. So data can be classified into two. Before applying the time series model, first we have to make it as a stationary data, then only you can go for this time series analysis. So here in this case, for the stationary data, if you take the mean and the variance of the time series, always it will be the constant for the whole data sets, for the whole series. Okay, so you cannot, this value will be constant. You can have n number of values, you can have it that. For all the values, if you take mean and the variance will be the same. That will, you cannot able to, I mean, it will be fixed actually. You cannot able to see the difference. So that is what we can call it as a stationary data. And then you have a non-stationary, or as I said already, it shows the trends and the seasonal effects you'll be having it. So here, suppose for example, the annual sales figure, if I want to find it out for the particular company, we can able to find it out based on the trend, whether it is going in the upward directions or in the downward directions, we can able to find it out. Next, we are going to see the different types of models we are going to see. First one is a auto regression model, and then the moving average model, auto regression moving average model. After that, the auto regression integrated moving average model. This is what most well-known model in the time series analysis. And then the seasonal auto-regressive integrated moving average model. So these are all the models we are going to discuss for the session. So auto-regressive model. So in the auto-regressive model, auto means it uses its past value to predict the future values. So that is what we can call it as an auto. So regression means that is used to predict the continuous value based on the parameters, certain parameters. Regressions, even we have under predictions also, we have a regression technique, y equal to alpha plus beta x is there. So there we used to draw one line. If you know the value of x, we can able to predict the value of y. Okay, so based on some parameters, we can able to predict some values we can able to predict. That is what we can call it as a regression in the prediction techniques. So here auto-regressive technique means here we are going to predict the future values based on the past. Okay, so here in the auto-regression techniques, here why it can be anything. So here it could predict the price of the stock price. Like this, you can write it as with a constant value and then multiplied with the previous time period, we can multiply it and then again with some constant value. So this is what we can call it as a first order auto regression. Suppose if it is in these equations can be written as suppose in the second order, if you want to consider it as a even the previous to previous time period also, if I want to consider, then in that these equations can be rewritten in this form, like again the constant value plus the constant value multiplied with the previous time period, and then again the constant value multiplied with the previous to previous time period also we are going to multiply. In this way only we are going to calculate the second order auto regression. So this is for example, suppose if I want to in this example, you are having a marks details throughout the schools. In the 7th standard, 59 marks. Suppose a particular student's got a 59 marks, and the 8th class a 60. Similarly, 9th, 10th, 11th also we are having some marks. So here, if I want to predict the 12th mark, so then in that case, what we used to do, the constant value plus the constant value multiplied with the 11th mark plus the previous value, even the 10th marks also will be considered, plus error value. This is how we used to predict the 12th standard marks. Okay, so this is an example for the autoregression model. So the next one is a moving average model also is there. So in this model, we are going to predict, here also we are going to predict the future value of the time series, but here we are going to use it as a past errors we are going to use it. But in case of autoregression, we are going to predict the future value. Here we are going to use a past value, we are going to use it. Past value in the sense, here we are going to predict the 12th standard mark based on the 11th and 10th marks, we are going to predict it. Okay, so that is what we can call it as autoregression. But here we are going to use the future value based on the past error, we are going to use it, not with the value. Okay, so that is the difference between autoregressive and the moving average model. Okay, so in the autoregressive model, we are going to predict the future value based on the previous values. But in case of moving average, we are going to use the past errors data, we are going to use it to predict the future value. Okay, so here we are going to use a error data, we are going to use it. See, in the moving average, if you take, we are going to have a mean value plus we have constant value multiplied with the previous error data, and then the current error prediction also we are going to use it. So based on that only we are going to calculate the y. Okay, so this is a difference between auto-regressive and then the moving average. So here we are going to predict the future value based on the previous value, but here we are going to predict the based on the previous errors, we are going to predict the future value. So for example, in the moving average model of time series, suppose for example, in the Uber cabs, here you are having a daily requirements is there. So this is an actual cabs detail, and this one is a predicted cab details we'll have it. So here in the day one, if you take, so here the predicted, we cannot able to predict anything. So, but the actual number of passengers are 4. So, but the error also we don't have anything. So in the second day, if you take, based on the previous data, we can able to predict it. Okay, so this is a formula we have, mean value plus the constant value multiplied with the error data plus, and then the current error data also we can have. So here what you are going to have, the mean value and then the actual value. So here for the second day, so here we are going to have a 4 minus 10. If you give the error value, you will get it as a 10. So if I want to calculate this, the third day means what you'll do, mean value here they have given it as a constant 4. So 4 plus the 3 is nothing but 0.5 constant value here they have given it as a 0.5. 0.5 multiplied with the minus 6, you will get it as a 3. So 4 plus 3, you will get it as a 7. And then the actual value. So here what you will get 7, and then the formula, when you apply this formula, the error value when you add it, so the here you will get it actual 14 minus 7, you will get it as a error value, you will get it as a 7. So actual value it was predicted as a 14, but in the prediction you will get it as a 7. Okay, so here even for the day 4, if you take, so there in the same way only it is going to be calculated, mean value plus the constant value multiplied with the error value, and then the if you add it, you will get some value. So that is a predicted value. So here also, when you see this, when you observe this value, it is also closely related to the actual value. Okay, so so in the moving average, this is how the error value will be considered. Based on the error value, future value is going to be predicted. Future value is going to be predicted. So so this is what we can call it as a moving average. So here we are going to take it into consideration. Error we are going to take it into consideration, and then based on that, we are going to predict the trend. Okay, so that is what we can call it as a moving average. So next one is see here two functions we'll be using it. One is autocorrelation function, another one is a partial autocorrelation function. We will use it. So this autocorrelation function is used to measure the correlation between the current period time and the previous time lags. So mainly for that purpose only we are going for this autocorrelation function. Generally for moving average, if you take, they used to find it out the autocorrelation function, because we mainly correlation, for what purpose we used to go for the correlation, among the attributes we have to find it out how far one attribute is closely related to the another attribute. For that purpose only we are going for this correlation. So here generally they used to go for the Pearson correlation coefficient. There if you get -1 means then there is no correlation. If you get one strongly correlated, if the I value is increased, then the Y value also will get increased. So strong correlation will be there. If it is -1 means, if the X value is in upward direction means Y you will have it in the down direction. So that is what we can call it as a autocorrelation function. So generally for moving average, they used to go for the autocorrelation function to identify how far one attribute is closely related to the another attribute. Even we have a partial autocorrelation functions also we have it. So this will be used for the autoregression. Okay, so just now I told you the correlation means generally used to identify the how far one attributes or two variables, how closely it is related to each other. For that purpose only we will go for this correlation. So autocorrelation is nothing but the relationship of the variable with the previous time period values. Okay, so that is what we can call it as a autocorrelation. So generally for autoregression, on the autoregression we will use a partial autocorrelation, we will use it. Moving average, they will be using a autocorrelation. They will be using a direct and the indirect effect of the values in the previous time lags. So there, suppose if I want to predict 12th mark, if I want to predict it, sometimes they will be considering a 7th, 9th, 11th marks also they will be considering it. Based on that also they can able to predict the 12th mark. Okay, so that is what we can call it as a autocorrelation functions. There you will have it as a direct or indirect effect of the values also. In the previous time lags also they'll be considering it. But here in the partial correlation functions, only direct effect of the value, only the previous times. If I want to calculate the 4th day, means then the previous day only, 3rd day, 2nd day only it will be considered. Based on that only we can able to predict the 4th day values, they can able to predict it. So this is an example for partial autocorrelation plot. So here in this graph, suppose here these are all the total number of lags we are having it. So in the x-axis, in the y-axis you'll be having a values will be there, 0.01. P values will be there. So always in the time series analysis, if it is above 0.01, if the p value is above 0.01, then in this example only these two days, if you take only these two lags only, it will be considered into the consideration. That means what? Two previous values only it is going to be considered it. for the future value. Okay, if I want to predict the y value, then in that case what they will do, they will try to consider the previous two values only it is going to be considered. So which are all the values it is going beyond the 0.01, only those values only it is going to be considered. Suppose if the third value is also, if it is above 0.5 means, then the third term also it is going to be considered. C4 yt minus 3 also will be considered. So this is how the number of terms will be considered, or the orders will be considered. Okay, so how many number of orders which should have to be considered means, based on this ACF and PCF, based on this ordered value only, the number of terms can be considered for the y. Okay, so if it is above 0.1 means, then the two terms, here in this example only these two terms only it is above 0.1. So in y can be calculated as constant value plus C2 multiplied with the y t minus 1, and then the C3 multiplied with the y t2 minus t minus 2. Okay, so this is how the values is going to be calculated. So generally PACF is used to measure the direct effect of the previous time lags on the current value. Okay, so for the current value, based on the previous time lags only it is going to be calculated. So generally this PACF is used for the auto regression model, but in case of ACF we will try to use for the moving average model. So in case of ACF, if you take, they'll be considering both direct as well as the indirect effect of the previous time lags. They'll try to consider it. So here they will try to see that the number of values crossed above 0.1. They will try to see, based on that only the order will be calculated. Okay, so next one is a ARMA model, auto-regressive moving average model. So in this model, already we have discussed about the auto-regression model, moving average model. The combination of these two only we are having it in the auto-regression moving average model. So here already we have seen that auto-regression model, we are going to predict the future value based on the past value. Okay, so we are going to predict based on the past value. So this is even equations also we have discussed it. So why there's a current value can be predicted based on the some constant value plus constant value multiplied with the previous value, okay, and along with the error. Okay, so this is how we used to calculate the auto regression model. Even in the moving average also we have seen that this can be calculated, the current value can be calculated based on the past errors. Okay, your current value can be predicted based on the past errors. So here the mu value or beta naught plus theta 1 multiplied with the error, previous error, and then the current error. So based on these value, it will be calculated, moving average value will be calculated. Okay, so the combination of auto regression and then the moving average, both together only we can call it as a ARMA model. Okay, auto regressive moving average model. So here in this case, if you take the AR model, so B naught plus beta 0 plus beta yt minus 1, and then plus this value errors also will be considered. So previous values also will be considered, previous errors also will be considered in case of ARMA model. Okay, so this is how we used to find it out for the ARMA model. Okay, so this is another example for how to find it out, the order of ARMA model. So here, based on, already we have discussed about the auto autocorrelation function, and then the partial correlation, partial autocorrelation functions. Based on these two parameters only we can able to identify the orders. Okay, So here autocorrelation functions. So in this case already we have discussed, even in the moving average itself we have discussed. They will see the p-value. If it is above 0.1 means those values will be considered. Those lags alone will be considered. So here in this example, the total number of lags above 0.5 is totally 3 lags are there. So 1, 2, 3. So that is why the Q value here they have given it as a 3. But in case of partial autocorrelation function, so in this function here the number of values here in this case they will be considering it as a in the AR model. If you take it out, only these two values, only these two lags only it is crossed above 0.1. So that is why AR will be considered as a 2. Okay, so based on the autocorrelation functions and then the partial autocorrelation functions, based on these two functions, we will try to find it out the order of ARMA model. Okay, so that will be represented as a P and then the Q. P is nothing but the aggressive model, and then the toe regression model, and then the Q is nothing but the moving average model. Okay, so this is how we can able to find it out the order. So next one is a ARIMA model. So in the ARIMA model, this is also similar to the ARMA model. Just there is a slight variation is there. Here we are going to have it as I is nothing but the integration. Integration is nothing but the differencing the operation to convert the non-stationary item to the stationary series. Okay, so based on this integration, based on this D value, we will try to convert the non-serious data into serious data. Okay, so non-stationary data, we are trying to convert it into a stationary data. That is a job for the I. Okay, so that is what auto regression already we have seen that. Even the moving average also already we have seen that how to calculate it. In ARIMA model, what we try to do now, so we will try to find it out the difference also. We will convert the given stationary, non-stationary values, we'll try to convert it into a stationary values. Okay, after that only we'll try to go for the time series model. Okay, then only you have to apply the time series model. Okay, so we'll see an example so that easily you can able to understand. So generally ARIMA model, totally we are having it as a 3 arguments. One is nothing but the order of AR model, and P is nothing but the order of differencing to get the stationary series, and Q is nothing but the order of moving average model. So generally ARMA model, 2 arguments we have, one is P, another one is a Q. But here in ARIMA model, we are having it as a 3 arguments, P, D, Q. Okay, P is nothing but the order of AR, D is nothing but the differences to get the stationary series, and then the Q is nothing but the order of moving average. Already we have seen that how to calculate the order of AR, order of MA. If I want to calculate the order of MA, for that we will use a partial autocorrelation function. Here if I want to calculate the order of our AR means we will use a partial order correlation functions we will use it. For moving average we will use a autocorrelation function. Okay, so based on this we will develop a model. Okay, so if I want to go for the implementation part, okay, so first we should have to know how actually this ARIMA model is working. Okay, so then only we can able to go for the implementation. So in the ARIMA model, so first we'll download the data set, and then we'll try to convert the time series data into a stationary data by using ADF function. Using this function, first we will check whether the given data we will try to convert it into a stationary. And then once you have converted the given data into stationary, because already I told you time series data, before applying any model, first it should have to be converted into a stationary values. Okay, then only we can able to apply the techniques. any of the techniques we can able to apply it. So using ADF function or ADF test, using ADF function, we will try to convert the given data into stationary. So once if the given data is a stationary, then we will try to find it out the difference. So, and then they're using, because actually in ARIMA model, we needed three parameters are required. So one is a moving average value we needed, and then the autoregressive value also we needed, and then the difference. These are all the three parameters we need to calculate it for performing this ARIMA model. Okay, so after converting into a stationary, then we will find it out the difference, and then the using PACF function, partial autocorrelation functions, we'll calculate the P value, and then using autocorrelation functions, we'll calculate the Q value, and then we will pass this into ARIMA model. So after that, we will we will calculate the white noise test. So here, see, when you work with the time series data, see, just generally here they used to find it out the correlation always it should have to be less than 0. Okay, so generally y equal to the y test, the formula y equal to signal plus, because generally the given graph itself, if you take it out based on the signals only, it is going to be performed. So y equal to signal plus noise. So based on that only they'll try to calculate the test. So generally they used to perform this white noise test by using this Lunge box test. They used to try to perform it. Generally this test is an hypothesis test.
Ma'am,
that is used to,
ma'am.
Yes, ma'am.
Ma'am, can you check your speak the voice? Because some participants told that it is not audible.
Now is it fine, ma'am?
A bit louder.
Now is it fine, ma'am?
Yeah, sure. Thank you. Okay, proceed, ma'am. Proceed.
Okay, ma'am. Thank you. So generally in the Lunge box test, it's a hypothesis test that is used to check if the time series contains an autocorrelations or not. Okay, so based on this check, we can able to check whether the correlation is there or the given data sets, and then we can able to predict the future value. We can able to predict it. Okay, so these are all the steps we have to go through it. After applying this ARIMA model, then we have to calculate the accuracy. We have to calculate it. So based on the some error, mean square error, there are some errors. Using that technique, we can able to find it out how far your model is good or bad. Okay, so based on the techniques, we can able to predict. Based on the accuracy, we can able to check whether the model is good or bad. So this is how the ARIMA model is going to work in the R. Okay, so again I repeated. First we have to feed the data. We have to convert the data and into stationary. After converting it into a stationary, if it is not stationary, means again you have to convert the data. After applying ADF also, sometimes you will not get stationary values. Okay, so again we have to increment the D value, and then we have to convert it into a stationary. So once if the data is stationary, that means what? A mean value and the variance value, it should be same for the entire series, entire time series. If you take mean value and then the variance value, it should have to be same. Okay, if there is a difference, means again we have to find it out. We have to increment the D value. Okay, for the entire series, the mean and the variance value should be same. After that, what you have to do, we have to calculate the what is that moving average, and then the auto regression we have to calculate it using a PACF, partial autocorrelation and the autocorrelations. Using these two functions, we will try to calculate the P value and the Q value, and all these three parameters we have to pass it for the ARIMA model, and then we have to perform the Lunge box test. In that test, we will check whether the time series contains an autocorrelation is there or not. and then after that we have to forecast the into future. We'll try to predict the model, and then we will check whether the prediction is correct or not. So based on some accuracy measures, we'll try to predict it. So if I want to run the ARIMA model, first what we have to do, first we have to import the data set, and then we have to attach the data file, and we have to download all the packages. What are all the packages that is required for the ARIMA model? And I think here in this case, we used to go for the T series, and then they forecast these are all the two packages we'll use it for the ARIMA model. And then what are all the libraries that is required for the T series, and I think we should have to upload it. After that, we have to apply the test for the stationary. Okay, we have to apply the because before performing any function, what I told you, we have to convert it into a stationary. We have to check whether the data is in a stationary or not, and then only we have to apply this auto ARIMA model. Auto ARIMA model, this particular function will give you the best fit. Okay, no need to calculate it, because ACF, PCF, PACF and all, no need to calculate it. This auto ARIMA function will give you the always the best fit. Automatically it will be calculated, and it will give you the best parameters it will give you. And then what we have to do, we have to create a model, and then we have to diagnose the check options, and then we have to forecast the series. Okay, so this is how we used to execute the ARIMA model. We'll go for the implementation part. Now, is it screen is visible? Huh? Am I audible? First, what we have to do, we have to install the packages we have to install, and then we have to download the data set. So share price. So here I'm going to read the Excel file. I'm going to download the data set. I have already downloaded. Share price. First, we have to install the packages, and then we have to read the data set. So after that, we have to install the libraries. Okay, so we have to import the libraries. Library of T series. Forecast. These are all the two packages are required for implementing this ARIMA model. One second, let me check whether. Let me check, one second. Otherwise, I'll show you. Already I have executed. I'll show this implementation. If you want, I can execute it. One second. Once you read the packages, once you have downloaded the library files, after that, what you have to do, we have to attach the share price. Once you have done that, next step is we have to check whether the data set is in a stationary or not. Okay, so we have to check it out whether the data is in a stationary, because before applying this ARIMA model, what we have to do, we have to check it out whether the data is in a stationary, because when you execute this N225, when you execute this data, what is going to happen? See the values on the right hand side, the trend, the uptrend and downtrend is there. This is actually a non-stationary data is there. We have to convert this into a stationary. By using this ADF function, we will try to convert this into a stationary function. Okay, so once you have converted this into a stationary by using a differences, okay, by using this differences function, we will convert the given data set into a stationary. So once you executed, then if you see the plot, when you draw the plot, see here for the entire series, when you observe, mean and variance will be equal. Okay, for the entire series, it won't change it actually. Mean value and then the variance value will be the same for the entire series. Okay, so after that, what we have to do now, we have to convert the stationary. After converting the stationary data, then what we have to do, we have to pass that into a ARIMA model. So here once again you can check it out with the ADF function. When you see this, p value will be 0.01. Okay, based on that, we can able to confirm that the given data is a stationary. Previously, when you see that before the stationary value, if you see, p value will be 0.4968. It is above 0.1. So whenever the p value is above 0.1, first time itself, sometimes for few data sets, you will not get it as a stationary data. Okay, so for that, what you have to do, again, we have to go for the increment the d value. Okay, so then only we can able to get the p-value 0. Until you get this p-value 0.01, we have to keep on performing the differences. Okay, so once if you get the data p-value 0.01, then you can apply this in the ARIMA. Then you can go for the ARIMA model. We can able to apply the ARIMA model. Okay, so after converting the data set, then only we should have to apply this ARIMA model. Okay, so this auto.arima, what I told you, automatically this will calculate the parameters p, d, and then the q. All these parameters automatically it will be calculated. Okay, so p value is nothing but the moving average value, and then the auto regression value, and then d is nothing but the differences. Okay, so auto regression, and then the differences, and then the moving average value. All these three values automatically it will be calculated by using this function auto.arima. And then what we have to do, once you have calculated, we have to generate a model. We have to create a model. So in this case, what we will do, whatever the parameters we have calculated in the ARIMA, okay, so same parameters here itself we can able to pass it on. Okay, so ARIMA, the given data, and then data set, comma, vector value. This we can call it as a vector value, comma, the order equal to C of whatever the auto ARIMA parameters generated. Same value we can able to pass it out here also. Based on this value, we can able to generate a model. Okay, so once you have generated a model, so then what you have to do, okay, so once you have generated a model, so then we can able to check. Okay, so the coefficients value we can able to check it out. This only we can able to specify it in the paper. Suppose if you are trying to go for the paper publications, okay, so this is how you have to specify it. The vector value equal to intercept value 4 into e to the power of minus 4 means this is nothing but the 0.001. You can specify the intercept value plus AR1. Here actually A value is 2. AR order is 2. So 2 AR1 and AR2 is going to be generated. So now what you have to do? The vector value multiplied with minus 0.7621 into t minus 1 plus 0.0375 multiplied with the Rn 255 and then t minus 2. So totally 2 orders we are having it plus moving average value and then multiplied with the error. Okay, so this is how you can write it in the equation. This you can specify it in the paper also whenever you are going for the publication. Okay, so this value, this equation you can specify it in the paper. Okay, so after that, what we have to do? We have to perform the diagnostic check. We have to perform it. Okay, so diagnostic check how far your model is good or bad. After creating a model, okay, so we have created a model. After created a model, we have to check it out how far your model is good or bad. Okay, so based on the diagnostic check, we can able to check it out whether the model is good or bad. So here in this case, we will create a residual parameters. We'll try to create it. And so here we will check whether you are having a normal. Actually, there we will try to check whether you should not have any correlation. And here you have to check mean value should be 0. And then the normal distribution also should be there. Okay, so these are all the 3 checks we should have to perform are the diagnosis step. One is we should not have any correlation. Second one is mean value should be 0. Third one is you should have a normal distribution. Okay, so all these 3 check we will try to do for the given model. Okay, so now what we have to do? So after converting into residual, first we will check it out. See, when you see this ACF, here when you observe all the values, all the lags when you observe, it is less than the 0.1. Okay, so no problem for this. And then there is no correlation. And then what we have to do? We have to check it out whether there is any mean. So here also if you take it out, the mean value is also a 0. Okay, so there is no uptrend or downtrend. Here you don't have anything with that. So here the mean value is also a 0. And then we have to check it out with the normal distribution. We have to check it out. You should have to get a bell curve. We should have to get it. So okay, then only we can say that the diagnosis text is correct. Okay, so the residual is perfect. Okay, so when see based on these 3 tests only we can say that there is no correlation, there is no 0, mean value is 0, and then we will check for the histogram. Based on this only we can say that the model is better. Okay, so after that what we have to do? We have to go for a GG, when I mean box plots test, we have to perform it. See, once if all the diagnosis text is over, then what we have to do? We have to perform a box plots test by using a Lynch box test. Okay, so or box PS test. Based on this, we will try to find it. We will always the data it should have to fall in zeros. Okay, based on this test, we will check it out whether the data whether within this range or not. We have to check it out. So after that, what we have to do? We have to perform the forecast model. We have to perform. Okay, so there in this case, here we will try to specify the number of periods, how many number of periods you want to predict it. In future value, how many number of values you want to predict it. Okay, so based on that only we can able to say, next 10 values, next 10 records, I want to see the future value, what could be the output. Future events here we can able to specify. So this is a given model what we have created, and then the next 10 records we are going to predict it. So once you have done this, and we can see the data sets here, the forecast value, the 10.
Excuse me, ma'am.
Yes, ma'am.
Ma'am, the screen is still in the package rate share price. Is it? Am I right, ma'am? Because its screen is not moving. Only we can able to see the library T series forecast share price.
No, 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 no.
Yeah, that's what. That's what.
No, ma'am, I have changed it. I went into.
But it is not changing. Okay. That's what.
Ma'am, actually, I went into demo part actually.
Okay, ma'am. Thank you.
1 second, ma'am. I don't know. 1 second. Now the screen is visible.
Yes, ma'am. Yes.
Actually, I'm explaining this part only, ma'am.
But we can't see. That's what I.
Okay, thanks for telling. Thanks
Thank
for
you.
the information, ma'am. Thank you. Should I repeat it, ma'am?
I asked participant, ma'am.
Okay, ma'am, no problem. No issues, ma'am. Once again, I'll try to
I
repeat.
think one participant they raised a yes, please.
Okay, yeah, sure, ma'am. See here in the first, what we have to do, we have to install the packages. All the packages we have to install. Once we have done installation, see first step, what we have to do, first we have to import the data. Okay, so once you have imported the data, then what you have to do, we have to attach the data file. So here we have to read the data, and then the libraries also we have to import it. After that, what you have to do, we have to attach the data file. So once you have attached the data file, then what you have to do, we have to check it out whether the data is stationary or not. We have to check it out. So here, when you execute this, see here, if it is a stationary, means what you have on the right hand side on the graph, if you see, you can see the uptrend and downtrend, you can able to see. That means what? The data, whatever data we are having it is not a stationary data. Okay, so what we have to do, using ADF function dot test, we will try to convert the given data into a stationary. Okay, so now what we have to do, so once you have converted the, see here ADF test, what it will do, it will tell you the p-value. P-value, if you see 0.4968, you have it. So suppose if it is above 0.5, means that means what, the given data is 0.1. If p-value is above 0.1, means that means what, the given data is not a stationary. Then what you have to do, we have to convert the given data into a stationary. So by using diff function, we will try to convert the given data into a stationary and store it into a vectors. So here what we'll try to do, we will try to convert it into a stationary. So once you have done this, so then what you have to do, we can plot the data. See, when you plot this data, what will happen here, you see there is no uptrend, no downtrend. All the series, the entire series, when you observe, it will be same. Mean and variance value will be the same. Okay, so now if you calculate the ADF function, here you see the p-value will be 0.01. After converting it into a stationary value, here you will get the p-value as a 0.01. So now the given data set is in a stationary. Okay, so now what you have to do, Once you have converted the given data into stationary, then what you have to do? We have to apply the ARIMA model. Okay, so now what I see this actually this function, what it will do, this will calculate automatically p value, d value, q value will be calculated. Okay, so when you execute this function, when you observe this, automatically the ARIMA model will be, the parameters for p, q and d will be calculated. Okay, so here they have given, here you get the output as a 2, 0, 1. Okay, so automatically this auto.arima function will return the p value, d value, q value with a 0 mean. Okay, for the given data set. Okay, for the given series. So next, what you have to do, once you got this parameter, then what you have to do, we have to, or otherwise what we have to do, we have to apply this ACF, PCF and all with difference and all difference, we have to calculate it, nothing else. If you don't want to use this, then what you have to do, we have to calculate we have to call this function, ACF function, PCF function, and that we have to store it into P, and then the A, everything we should have to do it. P, D. P, so all these parameters we have to find it out. After that, what you have to do? Same parameter, whatever arguments we got it, whatever results we got it using auto.arima function, that we are going to apply in the ARIMA model. Okay, so this is a data set, comma, or the vector format, comma, order equal to C of 2, 0, 1. I'm going to create a one model. So after that, what I'm going to do, after creating a model, then what we have to do, we have to call this particular functions, ARIMA functions. So this, when you execute this ARIMA functions, there you can able to see a coefficient values you can able to see. Okay, so this only we can able to specify it in the paper. Okay, this coefficient only we can able to specify it in the paper. So this intercept is nothing but the constant value. So the constant value is 0.0001. So this is nothing but 4 into e to the power minus 4. That is nothing but the, we can, this is a constant value 0.001 plus, and then the, actually here the a value here, p value is 2. P value is 2 is nothing but the auto regression, you are having it as a 2 values. Okay, 2 previous data, 2 lakhs they are going to consider it. So here what you are going to do, the constant was 0.7621 multiplied with Rn 255 and then t minus 1 plus, after that the next ARIMA model 0.0375 multiplied with Rn 255 225 and then t minus 2. So 2 lags we are trying to calculate it plus 1 moving average value. So 0.748 and then the error also we should have to consider it. This only we have to specify it in the equation. Okay, so don't forget actually, whenever you are going for the publication, so after creating a model, once if you execute that particular model, then this equation only we have to specify it, that you try to convert it as a equations. Whatever coefficients value we are trying to have it, that only you should have to convert it as a equation. After that, then what you have to do after converted into a equation, then what we have to do, we have to go for the diagnostic check test. Okay, so here what we'll try to do, we will try to create a residual parameter and we will check it out whether the mean value is 0 and then whether there should not have any correlation, and then we will check it out. The histogram also we'll try to check it out. So if I want to check for the correlation, then we will use this particular function ACF of ET. Okay, so using this function, we will try to check whether there is any correlation is there or not. We will try to find it out. Okay, so here when you try to execute this residual parameter, then what we have to do, we have to check it out whether there is any correlation is there. When you observe this on the right hand side graph plot, there you can see that all are within this range only we are having it. Okay, none of the lags are above 0.1. Okay, so that means what? There is no correlation. And then if you that means what? Mean value is 0. Okay, so that means what? Mean value is 0. And then what you have to do? We have to check for the normal distributions. Once if you go for the normal distribution, you should have to get a bell curve. Okay, so like this, you should have to get it. Then based on this, we can say that you are having it as a normal distribution. Okay, so what is the use of this bell curve? Means that means what? You are having it as a normal distribution. Once if all the test cases are passed, then we can go for the box plots test. Okay, so here in the box plots test, there we will try to find out the p-value. So here we will check this fit df, here the degree of the freedom. So degree of freedom here, this is nothing but the we have to subtracted if the value is series of the residual, 3 series of the residual, we should have to keep on subtracting it. So it is actually the combination of how we got this 3 is nothing but the it's a combination of AR and AR is nothing but the 2 and moving average is 1. So both together we have to add it and we will get it as a 3. Okay, so after that, after performing this test, then what you have to do? We have to go for the forecasting. Okay, so when you go for the forecasting, see here in the forecasting, next 10 records we are going to predict it. Okay, so for the given model, okay, what we are going to do? Next 10 records we are trying to predict it. So when you display this value, so when you display the next 10 records, this is how you'll be getting it as an output. When you want to see it as a blocks, when you want to see it as a plot, 1 second. Here you see, when you observe this, here you will get it as a next 10 sets, how it is going to future event we are going to predict it. If you want, you can have it, I can change the value as a 50. If you want, you can change it out. With the 10, if you want, you can proceed it, or otherwise with the 50 records, how if you want to predict how the data set will be, that also is possible. Okay, so in that way, we can able to predict the future value based on the past records. We can able to predict the future value. It is possible to predict it. Okay, suppose if I want to create a model starting from 1 to 1311, only these 3 data sets I want to consider. I want to apply this ARIMA model, and then I want to predict the remaining next 6 values I want to predict it. Suppose for example, here in this case, I'm going to create a model only up to this range, starting from 1 to 1311. Up to these data sets only I'm going to consider. I'm going to apply this model. Okay, so after that, what I'm going to do? I'm going to predict remaining 6 records. That means what? 1300 1312, 1313, 1314, 1315, 1316, 1300 something. For this 6 value, I'm going to predict it. Okay, so I'm going to forecast it. So once you have done this forecast, if you want to print it, this is what it is predicted. Okay, so 1312 to 17, we have predicted. Based on this ARIMA model, we have predicted. But already in the data sets, you might have some values, right? See, this is a original value, actual value, what we had it in the data set. Actual value here, the forecasted value here also positive, here also positive is there, so no problem. But here you are getting it as a negative, but here you are getting it as a positive. And then here also positive, we are in 2013, 1314. For this particular point, here also we are getting it as a positive, here also positive. Here we are getting it as a negative, here also we are getting it as a negative. And then for the 1316, for this particular point, here also positive, here also positive. And for the final data set, here also negative, here also negative. Okay, so this is a predicted value. This is a actual value. Okay, so 90% it is matching. Only this value is showing an error. Okay, so here we are getting it as a negative, but here it is a positive. Rest all the values are matching with the predicted actual value. Okay, so next what we have to do, we have to calculate the accuracy. So in this way, we can able to calculate the accuracy. See, usually, see here, always we will try to go for the, what to say, this MAP. This error always you should have to get it as infinity, because we always mean value is 0. So 0 divided by, something divided by 0, if you give, you will get it as a infinity. And then if you want, you can have it as a mean absolute error. This value also you can consider it. Okay, so in this way we can able to calculate the accuracy. We can able to find it out the accuracy. So we can say that the forecast model is better. Okay, so this is what we can able to calculate it. Even we have another data set is also there. Here also, as usual, we have to upload the data sets. And then what here I'll tell you how to calculate a ACF, and this is how we used to calculate it. See, once you have converted the given data sets, you have to install all the packages, whatever packages you want, entire packages, we can able to install it. Once you have done this, then what you have to do, we can calculate this test. If you want, you can calculate it. After calculating this test, but then what you have to do, we have to check it out with the we can calculate the p value, q value. Okay, so this is a function. Using this function, ACF function and a PACF function, we can able to calculate. If you want, you can go for auto.arima function. If you want, you can calculate using that function, and then the data set, if you give, automatically the p value, q value and d value will be calculated. But if you want, you can find it out in this way also. If you want, you can find it out, and then you can plot the value. You can create a model, and then you can predict the model. For the next 10 years, we can able to predict it. Okay, and then we can, if you want, you can test the model also. We can able to test the model based on this. If you want, I can execute it and show it to you. So once you have downloaded the data sets, here you can see the class label. This will tell you whether you are having it in a time series data sets or not. So once your data set is time series data sets, then you can able to see the start time series and end time series also. We can able to specify it. The start time series is 1949 1, and then end time series data set is 1960. The end date, the month is 12 months. Okay, so starting from first month to 12th month. Starting year is 1947 to 1960s. After that, what we are going to do, we are going to check it out the frequency. How many number of months we are having it? 12 frequency we are having it. 12 months we are having it. If you want to see the summary, the min median mode, first quarter, third quarter, maximum quarter. If you want to see that, you can, using summary, we can able to specify it. If you want, you can see the plot also. We can see here, you see when you observe this plot, it is showing it as a uptrend. Uptrend means what? The given data set is not in a stationary. Then what you have to do? We have to convert that into a stationary. So if I want to convert that into a stationary means, then what you have to do? We have to call this particular function. So this is the data set, complete data sets we are having it. I mean, this is actually cycle. Cycle only we are going to print it. If I want to see the data set, this is the data set. Okay, so this is a data sets for the air passengers. So if you want to, one second. If I want to view it as a box plot based on the number of cycles, based on the passengers, and then the number of cycles based on this, how many number of months each and every month they are traveling it. If I want to know each month, if you take it out, and month one, if you take it out, the number of passengers you can observe. if you want, you can view it as a blocks plot, and then, or otherwise, then what we have to do, perform the test. So once you have installed the packages, then what you have to do, we have to perform this ADF function. So the ADF function will, we can able to perform whether the given data set, one second. So this will tell you whether the data set is in a stationary or not. So if the data set is at a stationary, then we can say, then only we can able to perform that particular model. Oh my God. We have to download this also. We have to execute forecast. So now you see this ADF function when you apply. See here you will get the p-value. Okay, so p-value, if it is 0.01 means, that means what? The data is converted into a stationary. So once you have converted into the stationary, then here you see the lags all are above 0.1. Then what you have to do? We have to find it out the p-value, q-value, and then you can find it out the even the difference also we can find it out, and you can plot the graph. Once if you plot the graph, now you see the mean value will be 0. So whenever you find it out the difference, then what will happen? The mean value and the variance value will be 0. There is no uptrend and downtrend. So from this we can able to say that the given data set is in a stationary. So after that, what you are going to do? We are going to fit the model. So here we are going to using this ARIMA function. So whatever value we are going to get, whatever value we have calculated for ACF and then the PACF, based on this, we can able to fit the model, and then we can able to predict the data. We are going to predict the next 10 years how it could be, 1970 till 1970 how the values could be. So we are going to predict it. So there this is how we are going to predict the value. See, next 10 years what could be the output. One second, this is how it is going to be predicted. 1960, from starting from 1960 till 1970, this is how the values will be. Okay, so in this way we can able to calculate the future prediction based on the past record. If you want, you can check the records test also, starting from few values, starting from 1949 till 1959, because we are having till 1960s we have it, right? So test, we can able to test our model by using one second. If you want, I'll show you. So here what we are going to do for the same period, here we are not going to consider the auto, what is that, regressive, and then the difference is 1, and then the Q value is 1, moving average only here we are going to consider it. So based on this, so next, one second. So based on this, we are going to predict the 1916's original value. Only 1961 we are going to predict it. That's it. Okay, so this is a original value. Even the predicted value also we can able. Original value, if you want to compare, you can see that. This is how the original value will be. Okay, so this is the original value, and then the predicted values also we can able to compare it. Okay, so when you compare with the predicted value, so more or less it is somewhat better, but when you check with the accuracy, then we can able to see how far your model is working perfectly. Okay, so based on this also we can able to check it out. This is another data sets we have. If you want, I'll give this data sets also in the Word format. Both the documents I have given in the Word format. Even we have SRMIST model is also there. One second. This is how the ARIMA model is going to work. First, we have to install the data set. After installing, download all the library files. After that, we have to attach the data set, and then we have to convert the data set into stationery. After converting into stationery, then we have to create a model. We have to apply the model, or otherwise using ARIMA function, what we can do, we can find it out the p value, d value, q value, we can able to find it out. After that, we can create a model, and then we can go for the diagnosis check we can able to perform. Based on this check, we can able to see that the data, you don't have any correlation, me value is 0, and then the distribution also, normal distribution is there. After that, what you can do, you can go for the box perform, and then we can go for the prediction. Future predictions, we can up to 10 records we can able to predict it, and then we can go for the accuracy. So this is what we have to do it for the ARIMA model. Next one is a seasonal ARIMA model is also there. Seasonal ARIMA model means here also same thing, whatever we are having it for the normal ARIMA model, same thing here also we are having it, but here also in ARIMA model, what we are going to have, p value, d value, q value, we are going to have it. P value is nothing but the number of order of AR, then the differences, the number of first differences, and then the number of moving average, order of moving average. So here also same thing, here also we are going to have it, but here we are going to consider it as a seasonal. Okay, so generally we won't consider a seasonal in the normal stationary. What is a stationary data set? Stationary data set, if you take it out, there you don't have any seasonal trend, and then even the error data, random data also we don't have it. These three we don't have, not random data. Even cyclic also we don't have it. Okay, so the given data always it should, mean value, variance value, it should be 0. Okay, so suppose if your data sets, if you're having it as a seasonal nature, if you're having it, okay, so then what you have to do, then you need a consistency of a mean and the variance. Definitely, obviously, what you have it, the mean and variance will be changed. Okay, so normally for stationary items, if you take it out, you will have a different mean and variance will be there. This is how the uptrend, downtrend will be there for not stationary data set. But if it is a stationary data sets, if you take it out, this is how it looks a stationary data sets. Mean and the variance value will be same. Okay, so now what you are going to do, so here what we are trying to do, we are going to find out the difference. For season, what we are trying to do, we are going to find out the difference between the current position and the same point in the previous seasons. Okay, so based on these two values only, they are going to consider it as a seasons. Based on this, here normal ARIMA model, what are all the three parameters? Here also same thing, but additionally what you have along with the seasons, you will be having it. There what will be represented as a capital B, capital D, and capital 2 along with the seasons. Okay, along with the S value. Okay, so here this capital B is nothing but, already you know that ARIMA model PDQ, already you know that. This is nothing but the number of ARs or order of ARs, and then the differences, and then the order of MA, moving average. But here this is nothing but the seasons of AR, number of seasons of AR, number of seasons of differences, number of seasons of moving averages, and then the length of the season. Length of the season in the sense, if it is a 12, then you can specify it as a 12. If it is a 4 seasons, then you can specify it as a 4. Okay, so this is how we can able to specify it in the seasonal ARIMA model. So normal ARIMA model, this won't be there. Okay, this seasonal won't be considered for the normal ARIMA model. But in case of seasonal ARIMA model, this season values will be considered. That's it. Okay, suppose seasonal ARIMA model, or you can write it in this way. Suppose, for example, ARIMA of the AR value is 1, and then the differences is 0, and then the moving average is 1. So here, suppose if you have a seasonal AR, if you have a 2, and then the differences is 1, and if you don't have the moving average, and the totally 12 months you are having it. Okay, so how can we write this in the equation format? In the sense, what I told you, the WT will be calculated by the current minus T minus 12. 12 is nothing but the, what to say, one difference is only we are having it. That is why only one previous values only we are going to consider it. So YT minus the season, total number of seasons only we have to consider it. That is what we can calculate as a WT. So this WT can be returned as the W omega plus omega, or we usually we used to consider it as a beta value. Also we can consider some constant value we should have to be considered, plus pi 1 W, this is nothing but the WT minus 1, and then totally how many number of seasonals we have it? 2 seasons we have it. Each season we will have a 12 months we are having it. So pi 2 WT minus 12 plus next season 24 we have it. Second season we will have it as a 24. So pi 3 WT minus 24. If it is a third season, then it should have to be considered as a pi 4 WT minus 36. We can consider it. Plus theta. Next, what you have to do, this theta is nothing but the another value. 1 second. This the moving average value we are going to consider. Moving average value means what? The error data, previous error data value, and the current error data value we will be considering it. This is how it should have to be considered as an equation. Okay, this is how the season values also will be considered for the ARIMA model, seasonal ARIMA model. Okay. So these are all the different types of models are available in the time series analysis. Even we have a proprate is also there. In the proprate, what we will try to do, we will try to consider the holidays also. We'll try to consider it. Okay, so recently, I mean, Facebook proprate, another method is also there. There they will. I don't have. I mean, time, because of that I couldn't able to place it. I will give the link if you want, you can have a glance. Okay, because only few papers are available using propet. Okay, that is another algorithm, another method or another functions. Using that also they can able to predict the future value. Okay, that is also a time series analysis function only. Okay, so using that propet, we can able to predict the future value, which is possible to predict it. Link will be given in the end of the slides. If you want, you can go through that also, because limited number of papers only you can able to find it out using propet. Okay, so that's it. Any of them are having any queries?